All right, guys, for the final example of this lesson, we want to talk about the one up here. So, money deposited in a bank account earns interest on the initial amount deposited as well as any interest earned as time passes. This compound interest you'll find is something we're going to be talking about quite a bit as we get further on in the year. So, it's good to kind of go ahead and look at this expression as it's one that you will see repeatedly. This compound interest can be described by the expression P times 1 plus R to the n power. I know it's kind of hard to see that n, so I'll add a little n up there so it's a little easier to see. P represents the initial amount deposited, R represents the interest rate, and n represents the number of months that pass. How does a change in each variable affect the value of the expression? So, again, the expression, so we have our principal, so P, which is the initial amount. Okay, we have R, which is interest rate. And then we have N, which is the number of months. Also, sometimes we'll see it as a T for time. But in this case, we got number of months. So that variable could be different. All right, so the question is how are these, if I change one of these three values, how does it affect the overall problem? In general, we have P times 1 plus R to the n power. So let's talk about the P first. The P is separate. It's by itself. Okay? What I mean by that is it's a single factor in this problem. P is multiplied by everything else. P is multiplied by all this other stuff. So if P increases, the overall value will increase because you're increasing that factor. That's assuming that neither R nor N change. Just increasing your initial amount will increase the overall expression by a factor of whatever you increased it by. Okay, the opposite will happen if you decrease it. Okay, if you half the amount that P is, then you'll half the overall expression because it's its own separate factor. Okay, so let's go on and talk about R. So R is a part of the base of this exponent. So your exponent is up here, that's the n. The R is a part of the base, 1 plus R being the full base. So interest rates are generally going to be given as decimals, but the same conditions are going to apply. If you increase the R value, then the base is going to be larger, and so whatever exponent you're taking that to is going to also be larger, and therefore the overall expression will increase. On the other hand, if we decrease the value of R, then the overall base is going to be smaller, and the same effect will apply. You're going to end up with an overall smaller expression. How about N? Well, an exponent is the number of times that you are going to multiply that base times itself. So, for example, 2 to the third is 2 times 2 times 2. Okay? The N up there will tell us how many times we're going to be multiplying that base of 1 plus R times itself. So, assuming you're not going to mess with P, you're not going to mess with R, then if you increase the number of times that base is multiplied times itself, then you are going to probably increase the overall expression, assuming that this on the inside, okay, the base, the 1 plus R, this part, is greater than 1. Now, in our case, we have 1 plus a rate. Generally, you're not going to ever have a negative rate for a money problem. So, or not right now anyway. So this would be increasing because the base is greater than 1. However, if the rate were less than 1, or the overall base here were less than 1, then multiplying that fraction over and over again would actually decrease the overall value. Okay, so it really depends on what your base is, what the overall effect of N would be. Okay, now, to me, it's a little bit easier to kind of understand and see that if we look at it with some numbers. They didn't give us any numbers in the problem, but we can create our own. Let's say that we're going to start with an initial amount of $10. Okay? And we're going to have an interest rate of 25%, which is 0.25 for the math purposes. And the number of months, that's going to be 2. All right, so let's do our initial problem here with those things plugged in. So we're going to have an initial amount of $10, okay, and then we're going to multiply times 1 plus 0.25. We're going to raise that 1 plus 0.25 to the second power. Okay? And what that does, and you can use your calculator to check behind me here, that's going to come out to a total of 15.63. It actually is 6.625, but I'm going to round that up to 63 because we're going to assume we're talking about money here. Okay? Now, as we adjust and make some changes, let's see what happens. So let's say that we take our principal amount and bump it up to a 20. So we double it. But we're not going to change any of the other pieces. Okay? That's not right. So 1 plus 0.25, that wouldn't change to the second power. And when you plug that in your calculator, you get $31.25. So we increased the initial amount, we increased the final amount. The overall expression increased. What if we change one of the other variables? What if we instead go back to our initial amount of 10 times 1 plus, but instead this time we're going to go and change the 0.25 to a 0.5. But we're still going to do it for 2 months. What's the overall change there? It becomes $22.50. So not as big of an increase, but it did increase the value overall. Now we're going to do one last example where we change, you guessed it, just the last piece. So 1 plus 0.25. This time we're going to change this to a 4. Okay? And the overall effect that that's going to have would make the final value 24.41. So in this example, we increased each of the things individually to show that overall, by increasing those, you get an overall same effect. Now, it may be a different effect as to how much you'll actually increase it by, but increasing each one of those in this particular example does increase the overall value of the expression. Okay? So how does it change in each variable? That's what you would say. Each variable causes an increase or decrease in the overall expression. Depending upon the increase or decrease in each variable. Okay? So using these videos and using your notes, go ahead and continue this form, and also go ahead and start working on the rest of the assignments for this particular module. Have any questions, feel free to ask. Feel free to call me over to your desk with any part of it, and I may be adding some more videos to help with any other questions that you may have. Okay, good luck, guys.